What's up guys, Upward here, and this is Whilelab YouTube channel, and here we are with day 22 of 30 days of code, and today's video is about binary search trees. Let's go. First, what are binary trees? Binary tree or binary search tree is basically a form of organizing data. It's similar to linked lists. If you have seen in the, you can refer back to it in this playlist of 30 days of code. You can find it in the channel. You will see that we've discussed the linked list, and we said that linked lists are basically like you would have a node in the linked list, and it would have the data of the next node and the next node. So for example, this would be 1, this would be 2, and this would have data for the next node, and this would be 3, and if this is the last one, it would not have, it would point to null. That means it's the last item or the last node in the linked list. Now, in a binary search tree, it's similar, but the difference is instead of pointing to the next item only, it points to 2 items. Okay, so for example, this 3 would point to one of those like branches, you can say, but the difference is it's not just randomly doing like that, but if the number is less than the root, okay, so the first number is root, this is like the root of the tree, and if the next number is less than 3, we go left. If it's more than 3, we go right, then so on. So 5, now if it's less than 5, we go left. If it's more than 5, we go right, and so on and so forth. Okay, now what's the, like, why do we do that? This is like a way of organizing data. It's like a types of data structure. So when you come to search, you save time, because for example, let's say I want to look up for 4. I'll come here, okay, 3, I will not go here because I know it's bigger than 3, so I'll come here. Now we are on 5, all right, so 4 is less than 5, so I will not go right, I will go left, because 4 is less, so I'll find 4. That's it in a brief sense. So what is the challenge? The challenge is we will be getting a binary search tree, and we should get the height of the tree. How do we do that? Is we measure the longest branch in the tree and return that. So for example, on this, of course, we will not we don't calculate the root, so this would be 1, 2, 3, and since here are only 2, so the highest one is the 3, so the height of the tree would be 3. If we'd come here, you'd notice it over here. Okay, this is the node, and it would be sorted. Okay, they have written the code. I'll show you how they've written it. So this would generate a binary search tree, which is this one. Okay, 3, 5, 2, 1, 4, 6, and 7. The sample output we should give is 3 because the height of the tree is 3. Now let's jump in. Yeah, so as you can see here, we have this class called node. In this class we have now this is the node in the list, in the binary tree. Like this is a node, this is a node, this is a node. So yep, in this node we have 3 types of data. We have the right, we have left, and we have the data itself. So each node would, so this is, for example, this is 3. This is a node, so it would have the data of the left, which is the 2, the right, which is the 5, and the data of the node itself, which is 3. And then we have this solution. We have this method, they've written it already, which basically generates the binary search tree. So let us close this. The idea is that we should write here the solution. So what will be our solution is we will create a way where we loop through the nodes. Okay, so we come check this one and see, okay, go right, and if to see if it's higher, go up to the maximum and like store that number, and go in the left and see which one is higher and return that number. We'll call this method recursively. I'll show you everything. So first thing is we want to check if root is a thing, okay, because root might be empty. If root is a thing, we want to get the right, okay, the right side of the root, which would equal self dot get height, but we will pass root dot right plus 1. Okay, now why is that? So now using this, okay, so right would be self dot get height of the root for the right of the root, and then would increase it by 1, so we keep going. So it starts here, then it go here and go here and so on. Then we would do the same for the left, self dot get height, so it would keep calling this method. So it would come here, call this method, same method, and would come here and would check if it has something. It would come and call it and check of this node doesn't have a right and doesn't have a left, and so on. Now then we want it to return the max of those numbers. So which one is bigger? We want to return that. Then else we want to return -1. Now let us run the code now. Okay, it works. Good. Let's submit the code. Awesome. Congratulations. It looks good. So the question is, why are we returning -1? Okay, and let me show you. We are returning -1, so if root is not a thing, we will not move forward. Okay, so if we are here, for example, and we jump in here, then in here, then in here, then we jumped and we found nothing. Now why would we jump that? Because we are increasing 1 over here. Now if we didn't find this, we want to go the opposite way and go return to the last valid node. So yeah, that's it basically, and don't forget to hit that like button so I can continue, and yeah, that's it guys. See you in the next one. Peace out.